Welcome, here's a review of paper 1. Overall my class did pretty well at this. I was quite happy with a lot of your work, but let's run through all the questions. Skip if you're stuck to a particular one, and you can watch just that video. You should be able to scroll along the bottom on YouTube to see the different chapters. Each chapter is a question. Okay, first question, 38% as a decimal. 38 means 38 out of 100. That's obviously a fraction, but it means it's 38 hundredths. Hundredths is the second column along, so 0.38. The fraction in this shape that's shaded, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different parts of it, so I know it's going to be out of 10. If it helps, I don't think anybody miscounted this, but as you're going round, just check them off to make sure you've counted them, all of them, and obviously 3 of them are shaded. Right, smallest number from the list to start with, compare the first number of each one. Obviously only one of them starts with a 0, so it's 0.5. -9, add 5. When we're dealing with any negative numbers, adding and subtracting, think about a number line. Imagine it was -9 degrees. We're going to go up 1, 2, 3, 4, 5, so it gets -8, -7, -6, -5, -4, 1, 2, 3, 4, moving up 5. So the answer to this one is -4. Most people got this right. A few people couldn't resist the impulse to do 3, take away 2 to get your P as 1. In this case, though, we've got to do the inverse. It's something take away 2 that's 3. You can probably do that in your head, most of you, but what we're technically doing is adding 2 to both sides. So -2 plus 2, that disappears. 3 plus 2 is 5. When you've got any sort of solving equations question, just take a moment to sub it back in afterwards. So P take away 2, if I've got 5, that means 5 take away 2 is 3. For the people who put 1 because they couldn't resist doing 3 take away 2, if you do 1 take away 2, it's obviously not 3. So subbing it back in will save you marks in the long run. We did quite well on this. Some people got a bit overcomplicated. It says explain why one of the labels is wrong, not which one is wrong. I think the vast majority of you spotted that the diameter is not pointing at a diameter. And the easiest way to guarantee the mark here is just say what it should be. I think most of you would have known that that's the radius. If you just said the diameter label is whatever pointing at the radius, that is good enough. What isn't good enough is something like the diameter is only half. You've got to be really specific. It doesn't ask you to define a diameter. Those of you who did, if you defined diameter incorrectly, you lost some marks. So don't do extra work. If you wanted to say the diameter goes all the way across the circle, not just half the way, that would have been good enough. But the key point being, don't do more work than you need to. If you know what they are, just say it's wrong because of that. You don't need to go into a full definition. Right, on to question 7. 3 different factors of 20. Well, let's just look at how we find factors. You've seen me do this a million times on the board. I always start with 1. Does 1 go into 20 and how many times? Because you find factors in pairs. It does, 1 times 20. 2 also goes into there. 3, no, it's not in the 3 times table, that's 21. 4, yes, 4 times 5. When you get to the bottom and you've covered all the numbers to start the other side, you know you've done all 6. So that's, well, however many factors that number has. So 6 factors, any 3 of them will do. 1, 2 and 4 I'm going to put down. 2 free factors that come with everything is 1 and itself. So when it just says factors of 20, you should instantly know 1 and 20, and you only need to think of one more factor that goes into it. Here it doesn't ask you for a reason, so you don't need to explain it, but I think we're mostly happy with angles at a point sum to 360. So 0 take away 0, 0, 6 take away 5 is 1. So the remaining amount there is 310 degrees. Student says that an angle of 50 degrees is an obtuse angle. Student is wrong. Explain why. So there's two ways of explaining something's wrong. You can either give the correct answer. That's fine. So in this case, you could say something like 50 degrees is an acute angle. So you could, give the correct answer, and that's a way of showing why they're wrong. Or the other way is to explain why it's wrong in particular, and that's an obtuse angle. Obtuse angle is between 90 and 180 degrees. Lots of you said something like bigger than 60 or something. If you are going to explain why it's wrong, you need to be very accurate with your definition. So in this case, 90 and 180 was good enough, but saying bigger than 60 or not being specific doesn't work. In case you've forgotten as well, something bigger than 180 degrees is a reflex angle. They're the three types of angles: acute, obtuse, and reflex. Okay, generally really happy with the question. Point B, I don't think anybody put these the wrong way round. It's across to 5 and then up to 2. So well done, really common mistake, and nobody made it. Good sign. Plot the point with coordinates 4, -2 and label it C. So along to 4, down to -2. Again, I don't think I saw anybody going to like -2, 4, so well done on that. It says label it C, so I am going to put that. The mark scheme says unambiguously marked, so but if it gives you instructions to call it something, just label it C. I tend to give a cross as well rather than a dot. They're a bit more precise. Write down the coordinates and the midpoint of AB, so that's halfway between A and B, or there. I'm just going to pop it on to help me out, and then I can see it's across 1, up 3. Draw the line with equation y equals 4. Obviously we had some people drawing x equals 4 because it's easy to get confused between these. Y equals -4. The way I think about that is find any point that's got a y coordinate of -4, like x is 1, y is -4. Another one, x is 2, y is -4, x is 3, y is -4, and you can start to see the pattern. If you've forgotten which way around it goes, just find a few points and then draw it on. And I'm going to label it just to help the examiner out. That's y equals -4, and every point on that, the y coordinate is -4. People who drew the one up here, there, that's the x coordinate is -4. I know it's confusing, but that checking by looking at each cross can be useful. Right, Max is buying plates, and some people seem to completely skip this big part here about the special offer. Take a moment to read the question, not just at the beginning, but after you've finished your question as well, before you give your answer. So he wants to buy 6 large plates and 6 small plates using this offer. So every time you buy 1 large plate, you get 1 small plate for half the normal price. So every one of his small plates are going to be half the price. Now this is 4 marks. This should be a nice simple 4 marks if you're concentrating, because most people are happy to go. Large plates are going to be 6 times £2, which is £12. Small plates, little bit more complicated maths, because again he's getting 6 of them, but this time it's going to be half that price of 80p. Half 80 is 40p. 2 into 8 is 4, so it's 6 times 40p. Just put pound and 40p actually to show, so I don't get confused myself. So 6 times 40, well 6 times 4 is 24, so that's 6 times 4 is 24, so 6 times 40 will be 240. 240 pence is £2.40. So we've got, I'm just going to put the total as well, £12 exactly, plus £2.40. That means it's going to cost Max £14.40, and then just something very quickly, a conclusion mark. Yes, he has enough. Don't have to go into detail that £15 is 60p more than he needs or anything like that. Just, yes, he has enough money. So, key points from that. Read the question at the end afterwards as well. Just check back. It'll be a bit frustrating if you realise you completely missed something important, but this big box here, some people just picked up the key piece of information. It's £2 and 80p and then went with that. So max that. There we go. Right. Excuse me. 700 tickets were on sale and only 452 of them were sold. Not a popular place. How many were not sold? So 700 take away 452. Like one of those awkward subtraction ones you had when you were a kid. I haven't got enough here, so I need to borrow one from the next step. Because I can't do 0 take away 2. There's nothing there, so I'm going to have to borrow from here. Make that 6. And this becomes 10. Now I can borrow on from the 10, so it becomes 9. Make this 10. 10 take away 2 is 8. 9 take away 5 is 4. 6 take away 4 is 2. So I've got 248 unsold tickets. Just checking roughly. That's about 250. That's about 450. In my head, I can sort of see they're going to make 700. If I'd have got something in the thousands, I know obviously something's gone wrong. Different football match. Work out an estimate of the total amount of money paid for these tickets. Now, estimate. Lots of people wasted a lot of time on this question. Maybe you just had fun because you like multiplying things, but estimate, you can round everything. You can round all 4 of these things to make life easy for yourself. I saw some people try and do 297 times £9.50. Some people rounded this to 300 and so for £9.50 and 419.50, but we can do even better than that. Estimate, it expects you to use one significant figure for everything. So there's going to be 300 tickets at £10 each. 300 at £10 each. That's 300 times 10. That's going to be £3,000 on those cheap tickets. But then there were 400 sold for twice as much, sold at £20 each. So I've rounded 399 to 400, and £19.50 is about 20. I'm making my life as easy as possible. So 400 times 20, times it by 20, not quite as easy as times it by 10, but practically. I can times it all by 2, so I get 800, then times it all by 10, because I just need an extra 0. So that's going to be 8,000. So total money is what it's asking. Total money, 3,000 plus 8,000, that's £11,000. Much more complicated than it needs to be again here for you guys. When you see something that's worth 1 mark, you don't need to fill everything with a full explanation. Is it an underestimate or an overestimate? Well, everything has gone up. I've rounded everything up. So the actual values are all smaller than this. My values are bigger. My values are too big. It's an overestimate. It's a pretty good estimate, but it's an overestimate. So, overestimate, but it says given it reason. Overestimate. All values were rounded up. Now, I'll get in trouble for saying it, but you don't need to use full sentences. This isn't an English essay. Spelling is not as important as in many other subjects. We just need to get our message across as concisely as possible. It's an overestimate, all values rounded up. I didn't even write full sentences, just the key pieces of information. Right, question 12, the mean. Some people try to find the median. Median is the middle one. Nobody tried to find the mode. That's the one that comes up most often. This has no mode. The mean is when we add them all together and then divide it by how many there are. So I need to add these all together. So 13 plus 5 is 18. Excuse me. I'm going to write down as I go along. 18 plus 4 is 22. 22 plus 9 is 31. Plus 3, 34. Plus 8, 42. If you need to write that out vertically at any point, do. Don't be proud. Just do whatever you can to make sure you make as few mistakes as possible. So anyway, that's 42. But I need to divide it by how many there are. There are 6 numbers here. So dividing it up by 6, 42 divided by 6 gives me a mean of 7. Algebraic simplification, not bad this, well done guys. When we had multiplying involved it was a different story, but the adding and subtracting, pretty happy with. 15a divided by 3, you can think of this if it helps as 15 over 3 times by a. 15 divided by 3 is 5, so the answer then becomes 5a. Here I'm simplifying, this is collecting like terms. I've got some b's, I've got some c's, and I've got a 19. The 19 I can just put straight in. I know there's nothing else to mix it with. I don't need to do any more with that. The 19 can't mix with b's and c's. The b's can mix together. I've got a positive 5, take away 7. 5 take away 7 gets me minus 2b's. So I've got a minus 2b. I just tend to do mine alphabetically. B, C, constant. That's a positive 19. C's, I've got a 4c plus another c. So that's 5c's. So minus 2b plus 5c plus 19. And yes, you can have them any way round you want. Because in maths, 2 plus 3 is the same as 3 plus 2. So any order is fine. In the mark scheme, you'll frequently see OE, which is or equivalent. So anything that's the same as that. This was disappointing. We need to practice this. 8 and 6. What goes into them both? Factorising, finding common factors. Well, the factors of 8 are 1, 2, 4 and 8. The only one of those that goes into 6 is 2. So 2 is going to be what goes outside the bracket. And to go in the middle, to work out what's going there, I've got to do 8d divided by 2. 8 divided by 2 is 4. And minus 6 divided by 2 is minus 3. Once you're done, check it. 2 times 4d. Yeah, that's 8d. 2 times minus 3. Yes, that's minus 6. This and this are exactly the same. You have to have the brackets. You can't just write the bit in the middle. And every part of it needs to be correct. Right, question 14. 73% of the tickets sold were adult tickets. How many were not adult tickets? Well, that's everything else. I'm happy. I'll just adjust my focus. I'm happy you guys are all comfortable that 100% will be all of the tickets. So take away 73. I'm going to have to do the same borrowing again. So that becomes 9, 10, and I borrow one from there. So 10 take away 3 is 7. 9 take away 7 is 2. 27%. The percent's already written in there for me. Right, some ratio. Adults to children is 2 to 5. What fraction were adults? When we did this in the start grids the other day, I told you sometimes it's useful to write it out. The left one is adult, 2 adults, then children, 1, 2, 3, 4, 5. So that's like the 7 people. So out of 7. And what fraction were adults? Well, 2 of them were adults. So 2/7, not 2/5, 2/7, because there's 7 people in total. Another good example of how we should think about setting things out. Some of you did very well to work different bits out, but it was so difficult to work out what was going on, you might not have got marks from examiners. So, I've got a Friday and a Saturday. Kasim thinks more children watch the film on Friday than Saturday, so really what I'm going to have to do is find out how many people watch the film, how many children watch the film on Friday, how many children watch the film on Saturday, and we're done. So, Friday, let's do that first. I'm just going to write Friday over here so I know what's going on. 70% of 500. I love a ratio table, you know that. Percentage people. So 100% is 500 people. I need to find 70, so a couple of easy ones to find. 50% is easy. I can just halve that. So halve that, 50% would be 250. I can find 10% easily as well. I do that divided by 10, so 500 divided by 10. Let's just do another 10% because this might make my point a bit easier. I've got a 50, a 10 and a 10. If I add all those together, I'll get a 70, which is what I'm after. 70% were children. So a 50, a 10 and a 10, that's a 250, 50 and a 50. That's 350, so 350 children. That's Friday done. What about Saturday? So I'm going to do another ratio table. I'm going to have the fraction and the people. Now I need to find 5/8. So let's start by thinking about what 8/8 is. The whole 8/8 is the whole lot. That's 720 people. So that's 8/8, and I need to get down to 5/8. So to get from 8/8 to 5/8, I'll go via 1. I'll go divide by 8, then times by 5. So I've got to do 720 divided by 8. 8 into 7 is 0. Carry the 7. 8 into 72 is 9. No remainder. 8 into... Right, there we go. So 90. So 1/8 is 90. Now I've got to times it by 5. So I've got to do 90 times 5. Well, 9 times 5 is 45. Oops. Sorry. 9 times 5 is 45. Then add a 0. So that's 450. Right. So Friday was 350 children. Saturday, 450 children. Great. Just take a moment, read back. What have I missed? Well, Casson thinks more children watched the film on Friday than Saturday. Oh, well, he's wrong. There were more on Saturday. Now, when you've got your two numbers, that's good enough. You don't need to write a massive sentence. This is only a 3-mark question, but some conclusion's good. So is Cassim correct? And don't just write no up here very smallly, nice and big here. No more on Saturday. I don't need to write a sentence that says there were 450 on Saturday. That's 100 more than watched on Friday. Just they can read the work you've done if you've clearly labelled it. No more on Saturday is good enough. Right, question 15. Now, multiplying. My goodness me. Multiplying fractions. Some of you just see fractions and think, keep, flip, change. That's the thing I know. Adding and subtracting are complicated. We need to make the denominators the same. Dividing, we do the keep, flip, change stuff, the KFC. Multiplying is the easiest there is. I do the two numerators times each other and the two denominators times each other. So I get 6 multiplied by 5 over 7 multiplied by 12. 6 times 5 is 30. 7 12s, if you know your times table, this is a lot easier, is 84. Then I can start simplifying down. 30 over 84, well, let's go with something easy. I know 2 goes into both of them. That's 15 over 42. Then I might hopefully be able to spot, I know a few people didn't, they stopped here. Look for other factors. Obviously 5 doesn't go into 42. We know 5 goes into 15. So the only other ones are 3. Does 3 go into 42? Well, the digits sum to make 6. 6 is a multiple of 3, so that means 3 will go into both these. Divided by 2. Now I'm dividing by 3. I could have divided by 6 in one go, by the way. And dividing that by 3 gets me 14, so 5 over 14. The other method you might find useful is cancelling down almost before you get started. So instead of doing 6 times 5 and 7 times 12, I'm just going to swap these denominators. We can do that when we're multiplying. You can't do it in any other time, but we can when we're multiplying. So 6 over 12 times 5 over 7. Right, 6 over 12. Oh, that will simplify down now. Obviously 6 is half 12, so that's the same as half times 5 over 7. So now I've just got to do 1 times 5, that's 5, and 2 times 7, that's 14. Skips all this hard bit because I cancelled down before I multiplied. Don't worry if you can't do that, but it might save you a lot of time. Generally well done, this one. Harry's making biscuits. He's got a ingredients list, a recipe for 20, but he needs to make 60. So he's got to go from 20 to 60, which is the same as 1 to 3. He needs 3 times these amounts. 3 times as much. So if he was going to make it, he'd do butter times 3, sugar times 3, and flour times 3, and that would make enough for 60. So how much flour does he need is the question. So the flour is 250. So all this question is asking me to do is 250 times 3. Well, 3 times 0 is 0. 3 times 5 is 15. So I write 5 and then 1. 3 times 2 is 6. Add that one. 750 grams. Oh, okay. Counters in a bag. Some are red, some are blue, and then there's some yellows and greens. What percentage of the counters in the bag are yellow specifically? Right, so I'm going to look. I've got counters. Right, sorry, quick pause there. Right, so I'm going to draw myself a little table. I've got the colour, the percentage, and the amount. So colours I've got are red, blue, yellow, green, and I may as well work out the total as well. So what information I'm given? 200 counters in the bag, so that's the total counters in the bag. I also know that 100% is the total of anything. So 200 counters, I know 38 are red, 52 are blue. So you can see here, to get from the amount to the percentage, I'm halving. It's just another ratio table. So I'm going to divide by 2. So 38 divided by 2, 2 into 3 goes 1, remainder 1. 2 into 18 goes 9. So there's 19% of them are red counters. The blue counters, I'm going to do 52 divided by 2. So 2's into 5 goes 2, remainder 1. 2's into 12 goes 6. So that's 26%. Right, so I've got 19% red, 26% blue. I need to work out what's left yellow and green. So, well, actually, specifically, I need to know what percentage are yellow. That's the number I'm aiming for there. Now, I can see how much percentage I've used so far and work out what's left. So I've used so far 19 and 26. 9 plus 6 is 15. 1 plus 2 is 3 plus 9. So I've used 45% of the counters so far. So what's left? 10 take away 5 is 5. 9 take away 4. Right, so I've got 55% left. I don't know how many of them are yellow or how many are green. Except I do. It says it's the same of both. So I'm going to have to do 55 divided by 2. So half 55 and we're there. How many 2's in 50? 2, remainder 1. How many 2's in 15? 7, remainder 1. When you get a remainder and there's nothing left, just add a 0.0. So now how many 2's into 10? 5. 27.5%. There's lots of other ways you could have gone around doing that, but percentage, amount, a ratio table, again, always a ratio table. It gives me nice easy things. Okay, Naomi has B bags of apples and C crates of apples. 5 apples in each bag, 28 apples in each crate. She's got a total T. So T is the total number of apples she has. That's what I've got to work out. Down here I'm going to have T equals. I just work out what's there. Right, 5 apples in a bag. So I don't know how many bags she had, but if she had 10 bags, I'd do 10 times 5. If she had 2 bags, I'd do 2 times 5. 1,000,000 bags, 1,000,000 times 5. It says she has B bags, so I'm going to have to do B times 5. So the bags is B times 5, or 5B. The crates, again, I don't know how many crates she has, but if she had 10, I'd do 10 times 28 to work out how many apples. 2, I'd do 2 times 28. But she's got C, so I'm going to have to do C times 28, or 28C. So the amount of apples in bags is 5B. The amount of apples in crates she's got is 28C. Whatever they are, when I know what they are, to work out a total, I'd add them together. So I get 5B plus 28C. So key here, if you're dealing with things forming equations and formulae, just think of a couple of examples. Just imagine, instead of B bags, she had 6 bags. Instead of C crates, she had 5 crates. What sum would you do to work it out? Well, I'd do 5 times 25 plus 6 times 28, or whatever numbers I just said. Imagine some real numbers there, and it might start to make sense. Just looking at it like this seems a bit crazy and weird, and algebra scares some people. But you don't need to worry about it. Just think about a real example with actual numbers. Right, tough question here. I said earlier, multiplying fractions is easy. Subtracting and adding them a bit more difficult. Now, there's a few ways of doing this. I think the way that's a sort of foolproof method will always work, so sometimes will give you some tough numbers to deal with, is start by turning these into an improper fraction. So first off, I'm going to convert 7 and 3/8 into some amount of eighths. So that's 7. Each one of those 7s is 8 eighths. I've got 8 eighths, another 8 eighths, another 8 eighths. I've got 7 lots of 8 eighths. So 7 lots of 8, that's 56 eighths just there. And I've got a whole another 3, so that's 59 eighths. So I can write 7 and 3/8 as 59 eighths. Right, what about 2.5? This one's a bit easy. Maybe I should start with this for my explanation. Well, each one of those halves has got, each one of these is 2 halves. So I've got 2, 4, and an extra one, 5 halves. I'm essentially doing the big number times the denominator, add the numerator. 2 times 2, add 1 is 5. 7 times 8, add 3 is 59. Right, so now I've got these. Again, I still can't add or subtract them very easily until I've got the same denominator. So let's make this one eighths as well. I'm going to make the bottom and the top times by 4, so I get 20 over 8. Right, now I'm going to use these two instead of these two to work this out. So 59 over 8 subtract 20 over 8, which is 39 over 8. Almost there. I've got 2 marks. Done all that clever work. I've only got 2 out of my 3 marks. My final mark is because it wants it as a mixed number. So how many 8s go into 39? Well, that's almost 5. 5 8s would be 40, so it would be just under that. 4 8 is 32. I need 39, so 7 more 8s. So 4 and 7 eighths. A lot going on there. Guaranteed to be worth a few marks, because they'll just ask you a basic question like this, but it will come up at some other point as well. Tough question, this one. We want to work out the volume of the cube, and it tells us the surface area. So let's think about how you work out the volume of a cube first. Think about what I might need to figure out. Here's my little cube sketch. To work out the volume of a cube, all you need to know is the length of it, because the volume will be width times length times height, and because it's a cube, they're all the same. So if I know what that is, I can do x times x times x. So all I've got to do is work out how long one of these squares is. If I can work out how long one of those squares is, I can easily find out the volume of the whole cube. So let's just have a think about what it tells us. It tells us about the total surface area. So that's like if I had to cover all the faces of a cube, that's how much it would be. So think about how many faces there are on a cube. Just like a dice, there's 6. So each one of these ones, if I can work out how big each one of those squares is, the area, that's enough for me to work out the size. So if I know the total area is 150, the area of this one will be 150 divided by 6. Well, how many 6 go into 1? 0, remainder 1. How many 6s in 15? 2, remainder 3. How many 6s in 30? 5. Right, 25. So this is 25. Each one of these is 25 centimetres squared. 25. Hopefully you've become familiar with that number after all the Pythagoras stuff and all the squaring we've been doing. 25 is a square of 5. That means the side of each square must be 5 and 5. So 5 times 5 gets me to 25 centimetres. Then if I've got 6 25 centimetres, I'll have 150 centimetres squared. Excuse me, sorry. So, almost there. I've worked out the side length of the cube. Now I need the volume of the cube. Now I said a minute ago it was width times the length times the height. So 5 times 5 times 5. 5 times 5 is 25. Times by 5 again gets me 125 centimetres cubed. So the volume of the cube, 125 centimetres cubed. Alright, quick pause while I go have some dinner. Right, I'm back and I realise I missed questions 19 and 20. So, question 19. This is an nth term question. There's a specific way you need to write this. You can't just write going up in 8s. Well done if you spotted, by the way. That's the first thing, that each number is going up in 8s. Now the way to think about this is it's like the 8 times table. The 8 times table is 8, 16, 24, 32, 40. Now the 8 times table goes up in 8s and we call it 8n. 2 marks, one of them was for just having 8n written anywhere on your page. So it's going up in 8s. Our sequence though is a bit different. It's -5. I'm just going to write it again down here. I wouldn't bother if I were you, but just to make things a bit more obvious for us. What's happening to the 8 times table to turn it into this one we've got here? Well, to get from 16 to 3, that's the easiest one to spot it, I need to go down 13. I take off 13 here as well. In fact, for every one of these terms, if I take 13 away from it, I get to the one at the bottom. So if the 8 times table is 8n, this is the 8 times table take away 13, or properly called, oops, I've written plus, 8n take 13. So 1 mark for 8n, 1 mark for negative 13. Right, 846 divided by 0.15. Some valiant efforts here. I'm going to teach you long division pretty quickly, but the first thing I'm going to do is point out some of you did some excellent long division. The mistake you made was the wrong number of decimal points and things like that. With dividing, it's not actually too difficult. If I multiply the thing I'm dividing and the thing I'm dividing by 10, the answer's the same. For example, 0. Let me think about this. Okay, 4 divided by 2 is 2, and 40 divided by 20 is also 2. If you do multiply them both by 10, your answer stays the same. You don't need to do anything to your answer afterwards. So, if I multiply these both by 10, I get 84.6 divided by 1.5. That'll give me the same answer as that. And 846 divided by 15 will also give me the same answer as that and the same answer as that. So I'm going to go with this one with the whole numbers, get rid of a bunch of decimals. Still not the easiest division to do. Let's go for it. Giving myself plenty of space to work with. So, how many 15s go into 8? Well, 0, remainder 8. So how many 15s go into 84 is really the question. If you're struggling with long divisions, ones you don't know the times tables for, write them down. One of them is 15. 2 is 30. 3, 45. 4, 60. 5, 75. I've still not got up to 84. 6, 90. There we go. Right, so it's 5. 5 of them is 75. Now, long division, if you're interested in learning it again, I do, well, that was 75, and then I can work out what the remainder is, because I've got 84, 5 15s is 75. What's the remainder? 14 take away 5 is 9. So okay, remainder 9. So now I'm going to bring down the 6. It's like when we put the 9 as a remainder up there, and then I'm doing 96. So now I've done 15 into 84. I got 5, remainder 9. Now I'm doing 15 into 96. Well, I've already worked out that 6 15s is 90. 7 will be too much. So it's going to be 6. 6 15s is 90. So my remainder is 6. I've got nothing to bring down. So let's add a decimal point and a 0. So 15s into 60. Well, that's exactly 4. So 846 divided by 15 is 56.4. You don't need to do anything to that afterwards. I established with this reasoning I gave here, 8.46 divided by 0.15 is exactly the same as that, so 56.4. Alright, we've already done 21 and 22. 23, just forgotten what a frequency polygon is, a lot of you. I know you've got a lot to remember. Hopefully it's nice and easy. Frequency polygon is going to be a bunch of lines joined up. First off, you put them at the middle of the group. That's the important thing. So between 0 and 5, exactly halfway between it is 2.5, and I go up to 8. There. 2.5, 8. So I do that one at 2.5. This one's going to be at 7.5. That's halfway between 5 and 10. 12.5, 17.5 and 22.5. So I've got to plot these 5 points. 2.5, 8, 7.5, that's there, 1, 2, 3, 4, 5, 7.5 and 20, 1, 2. Oh no, sorry, 24. 2, 3, 4, there it is. 12.5 and 13. 1, 2, 3, 4, 5. That's halfway between 10 and 15. And I go up to, was it 13, 10, 11, 12, 13. Halfway between 15, 20 and 11. 11. And then 4. 1, 2, 3. 1, 2, 3, 4. Right. Okay, so that's one of my 2 marks. The second mark is for joining them up. Use a ruler. You just join the dots to each other in one go. For some reason, some people feel that because it's called a polygon, they need to join it up to something. You don't draw these extra bits on here. You don't join it up to each other. It's just that. It's just a trend. It's weird. I don't know why you've got to learn it. I've never seen anybody use these. You've got to learn it though. It's nice and simple. Quick 2 marks. Now you know. Right, Venn diagram. So this weird symbol means the complete set. This is every number, the universal set. So I've got to put these 10 numbers into here. I'm going to cross them off as I do them so I don't get distracted. Now, to help me out, well done to the people who did this and remembered when I taught you. These are square numbers, these are odd numbers. So let's go through them. 1, is it odd? Yes, it needs to be in this circle. Is it a square number? Well, I can't remember all my square numbers, so let me pause for a second and work them out. Oh yeah, 1 is a square number. What else? 2 times 2, 4 is a square number. 3 times 3, 9 is a square number. 4 times 4, too big. Okay, so they're my square numbers. So 1, 4 and 9 are going to have to be in here somewhere. Let's just do them first, shall we? 1, it is square. It's got to be in here, and it is odd. Done. 4, yes, it's square, but it's not odd. It's even, so it's going to go in here. 4's done. 9, it's going to go in this circle, and it is odd, so it's in both circles. Right, so I've done 1, 4, and done my square numbers. So now all the rest of the numbers I've just got to divide up. Are they odd? If they're odd, they go in here, and if they're even, they go outside. Nothing else is going to go in here. So odd numbers, 2 is even, so it goes on the outside. 3 is odd, so it goes in the middle. 5 is odd, so it goes in the middle. 6 is even, goes on the outside. 7 is odd in the middle. 8 is even. 9 I've done. 10 is even. Done. So I've got 10 digits in here. If you just look at your odd circle, you should just see all the odd numbers. 1, 3, 5, 7, 9. Brilliant. And in here, I see all the square numbers. 1, 4, and 9. If I cover up the odd circle, I should see all the even numbers. 2, 4, 6, 8, 10. Brilliant. Job done. Okay, now we randomly choose a number. So we're going to randomly choose one of those 10 numbers. What's the probability that it's in B dash? Well, first off, it's going to be some amount and amount of 10. That, by the way, was worth a mark. Just anything out of 10 was worth a mark. So find the probability this number is in the set B dash. So a bit of revision on these might help. Lots of you just saw that and thought, B, oh, it's going to be what's in here. And well done, you looked in there and you went, oh, there's 3 of them, so it'll be 3 out of 10. But B dash, B prime, means not B. Not B. So everything that's outside of B, that's 1, 2, 3, 4, 5, 6, 7 out of 10. So that little dash completely changes the question, makes it go from 3 out of 10 to 7 out of 10. Okay, scatter graphs. Some of you got a bit lucky on this one, but describe the relationship between the age and the weight of babies. Keep it simple. Okay, age and weight of babies. You could say, for example, well, I don't know if you remember, it's called positive correlation. Maybe you don't remember that when it comes to the exam, so make it really simple. As age increases, weight increases. I'm just assuming, by the way, I'm pretty happy that you all sort of know how to get that from this diagram. So age increases, weight increases. Right. Yeah, that's good enough. Or the older the baby, the more it weighs. The heavier a baby, the older it is. Anything like that. Another baby has a weight of 5.8. So 5.8. So it's somewhere up here. Using the scatter graph, find an estimate for the age of the baby. Now, the best way to do this is to draw a line of best fit. Draw it somewhere. I turn my ruler on end like this so I can see I want about half of them on each side, and I want it to sort of generally follow the curve. That looks good enough to me. It does not need to be perfect. That's probably a little low. No, yeah, I think there's probably more of them above them. But anyway, that's good enough. So the baby has a weight of 5.8, so that would be up here. 5.8, so I'll read that going down. I reckon that is about 2.12. Oh, these go up in 2s, don't they? Because that's 4, so 3.8. About 3.7 months old. You were given a huge margin for this. This is why I wasn't saying I'm spending ages trying to work out my line of best fit, because your mark was for anything between 2.5 and 4.5. It's a massive range. Anything in that area there, basically. So if you just sort of gone, it's about 6 across, some bit down, you were almost certainly going to end up between those two. It really doesn't, really massive margin for error. Anything between 2.5 for 2 marks. So that's how we work things out on scatter graphs and get in there. Price of a holiday increases by 20%. Impressed with how many of you use percentage and ratio tables. Well done. So it increases by 20%, and the increase is £240. Work out the price of the holiday before the increase. I'm going to do, guess what? A table. Right, so the number I know is £240. Now that's not the price of the holiday. It'll be the cheapest holiday ever. That's just the increase, and the increase was 20%. Now some of you tried to find 120%, which was the total price including the increase. We want to find it before the increase. So the original price of the holiday, we want to find the 100%. A few ways of doing that. You could just multiply this whole thing by 5 if you're comfortable multiplying by 5. I'll just play around a bit. I'm going to double them both because doubling is easy. So that's 480. Double them both again. 960. And then to get to 100, I'm going to take the 20 and the 80 and add them together. So that's 240 and 960. 0, carry a 1, 3, 12, £1,200. And they added £240 on because £240. Oh, hold on, I just realised something's gone wrong here. Nope, turns out I was right. No problems with that. Okay, on to 27. So, tough question. Well done to people who got it right. But gives us the stuff about pressure, and it's telling us, let's just first off work out what we've got. We've got some cylinder resting down, so something that's pushing down. And it tells us the volume of it, it tells us the height of it, and it tells us how much force it's exerting downwards. It's exerting 90 newtons down. And I've got to work out the pressure. So pressure is obviously the force divided by the area. It tells us that here. I need to work out the pressure. And I'm told the force. So I've just got to work out the area. The area is which bit of the cylinder is pressing down. It's like if you're walking in snow. If you're wearing giant, great big snow things, you're going to put less pressure downwards. You're going to sink less deep in the snow. Whereas if you just walk on a foot, you can sink straight in. Don't worry if you don't understand the explanation. The main thing is this is the area we're looking for. So how can I work that out? Well, I'm given this information about this cylinder. I know it's 40 centimetres high. I know the volume of it. Hopefully you'll remember, because you're not told, the volume of a cylinder is pi r squared times h. Or, because it's a prism, the volume is the cross section, the area of the cross section times the height. Well, I know the volume and I know the height, so I can work out the cross section. The volume is 1,200, so that must be the area of the cross section times 40. So to solve this, think of it like an equation. I'm going to divide the opposite of times in by 40 is dividing by 40. So I've got to do 1,200 divided by 40, or 12 divided by 4 is 3. Then take off a 0 because they'll divide, so I get 30. So the area is 30 centimetres squared. So I've got 30 centimetres squared, a force of 90. Let's just check that's right. How do they want this? They want newtons per centimetre squared. Brilliant. I've got newtons, I've got centimetres squared. Amazing. So all I've got to do now is plug that all in. Pressure is force over area, which is 90 over 30. 90 divided by 30 is 3. 3 newtons per centimetre squared. 3. Go and watch some Sparks stuff. This wasn't the easiest pressure question if you've completely forgotten pressure. But the key things are pressure, force and area. Okay, if you can work out the area, you're away. Right, when you get something like this, some of you just saw simultaneous equations and went, oh, we've done these, I know how to do these, and did a whole page of work. It's 1 mark. look closely. 2y is 3x minus 22. That's this line. 2 minus 2y is x. That's this line. I'm looking for the point where they meet, where they're both true simultaneously. It's there. X is 2 at that point. Y is minus 2 at that point. X is 2. Y is minus 2. 1 mark. If you see 1 mark, you shouldn't be trying to solve massive simultaneous equations. Something has probably gone wrong. Right. 29. Bit awkward. Those of you that tried, well done to those of you that remembered the indices laws. The indices laws are important. In this instance, are what happens when we times two things together. We add the indices, we get x to the power of a plus b. And then the other rule is what happens when we divide them. When we divide with indices, we subtract a minus b. So let's apply them in this instance. I'm just going to sort the numerator out first. Actually, I can also, something that's useful is when you don't have an index, it means it's 1. So 4 to the power minus 6 times 4 to the power 9. So that's, I'm going to add them together. Minus 6 add 9 is 3. So I'm going to rewrite this, but just change the numerator for, instead of a minus 6 and a 9, 4 to the power of 3 divided by 4 to the power of 1. Now I can use this next trick, subtract them. So 3 take away 1 is 2. So what this question is actually asking me to do, it looks dead difficult, but the only the only actual calculation I need to do is 4 squared. 4 times 4, well that's 16. Cos 60. I've shown you a couple of ways of remembering these. My method is start with a triangle, which is equilateral, all the sides are 2, all the angles are 60. Then chop it in half. So I get this triangle here, 60. This side's half as long, so it must be a 1. This side's twice as long, so it must be a 2. And I'm after 60, so that's my opposite hypotenuse adjacent. Cos it's SOHCAHTOA. So I'm after this triangle here. Cos is equal to the adjacent divided by the hypotenuse. The adjacent is 1. Hypotenuse is 2. It's a half. If you've got a really good memory, remember all of these. You've got to remember 30 and 60 for sine, cos and tan. So 6 of them you've got to remember. If you've got a great memory, do it, or learn that hand trick I showed you where you count the number of fingers above and below. Scrub them up on it just before your non-calculator one. You've only got to know it for your non-calculator one. Sometimes it's just worth 1 mark like this. Frustrating, this was the only trig type question after we spent so much time on it. The final one, clearly we need to do some revision on probability. Probability tree is 2 things. Once you've read all this, you see that actually what we're really interested in is just work at home on Monday and the office on Friday. So that's this route, home, office. So going along there. So probability of working at home is 0.2. Probability of going to the office is 0.3. To work them out, you multiply them together. This one, to work this out, would be 0.2 times 0.7. This one's 0.8 times 0.7. 0.8 times 0.3. We don't need to worry about those 3. They're not the results we're interested in. I could work them out, no problem, but I'm interested in this one. 2 times 3 is 6. And then, because it's got 2 numbers after the decimal point, 0.06. And there we go, that's the final one, 2 marks. If you remember how to do that, that's a nice gentle end to the paper. If you don't, it's going to look like a complete mess to you. We'll do some probability revision based on how well that question went. Right, thank you very much. Well done, and I'll see you on paper 2.